So today we'll discuss the non-homogeneous system of differential equations and the diagonalization method to solve such system. So let's start today's lecture. So screen is visible to you?
Yes, ma'am.
Okay. So we have non-homogeneous system of equation. Of equations. Equations are differential equations. System of first order differential equations. Okay, that means non-homogeneous means x dash ax plus some function of independent variable t, right? So because this is the non-homogeneous one, so it is understood that it will be the function of t, right? Means simply you can write in this form, x dash is equals to ax plus f. Now because we are using the diagonalization method, that means this A matrix should be diagonalizable. So we'll make a substitution because this type of equations are coupled equations. So to make them uncoupled, we'll make a substitution. X is equals to py, right? So we'll substitute all the values like x dash and xpy in equation 1. So equation 1 becomes py dash. See, when you take its derivative with respect to t, because these are the dependent variable x and y, so you can take, but p is the matrix. So matrix means you cannot differentiate any matrix. So py dash is equals to a py plus f, right? Now pre-multiplying by p inverse. That means P inverse P, identity matrix with some matrix, column matrix, will get the same matrix. P inverse AP Y plus P inverse F, right? So Y dash is equals to D Y plus P inverse F. Now you need to solve this. Okay, in the homogeneous one only we were having up to here, but for the non-homogeneous P inverse F. That means you have to determine P inverse. For example, solve this. Dx by dt is equals to 4x plus 2y plus 3e power t. Dy by dt is equals to 2x plus y plus e power t. So first we'll write the corresponding matrix form, x dash y dash, right? 4 2 2 1 x y and 3e power t and e power t, right? That means x dash is equals to ax plus f form. That means non-homogeneous system of differential equation or first order differential equation. Now using diagonalization method means first we'll find the eigenvalues of this matrix. That means a minus lambda I is equals to 0. So directly I'm writing eigenvalues are 0 and 5. Okay, that you need to determine. At least you need to write the characteristic equation in terms of lambda, right? Then This corresponding to 0, eigenvector is 1 minus 2, and corresponding to 5, eigenvector is 2, 1. Right? That means you will get a P matrix, model matrix as putting them in a column 1 minus 2, 2, 1. Okay, so when you find its inverse, because see, we need inverse here, P inverse F. So P inverse will be 1 by 5 minus 2 by 5, 2 by 5, and 1 by 5. Now, you need to mention let x is equals to py, right? Where y is equals to, y dash is equals to dy plus p inverse f. That means we'll find y using this. So when we make this substitution, we'll get this. Now, for this, we need to find P inverse F dy, right? So let us substitute all these values. Dy, you know how to find dy. P inverse AP, you will get D. So once you have mentioned P and P inverse, no need to calculate. If your P inverse is correct, definitely you will get D matrix as 0, 0, 0, 5. Eigenvalues on the principal diagonal. Okay, so directly you can write D. Now everything you have, D you have, Y you have, P inverse you have, F you have, substitute all the values. So when you are substituting, you will get two equations in terms of means first order differential equations. That I'm getting one poll, just hold for a second. So we have the equation y dash is equals to dy plus P inverse F, right? So let's substitute the value. This is 0, 0, 0, 5. Y means y1, y2 types, right? And y dash is y1 dash, y2 dash. Then P inverse plus P inverse. Let me see the value. 1 by 1 minus 2 to 1. So 1 by 5 minus 2 by 5, 2 by 5, 1 by 5. And F value is, it was 3 e power t and e power t, right? So when you are multiplying this, 0 y1 plus 0 y2, that means 0. 0 y1 plus 5 y2, that means 5 y2. Okay. Now when you are multiplying this, see order 2 cross 2, 2 cross 1. That means you will get matrix of order 2 cross 1. So 1 by 5, 3 e power t. That means 3 by 5 e power t. Then it will be multiplied by this. That means 2 by 5 e power t. Then 2, 3 just 6 by 5 e power t. Then 1 by 5 e power t. This is y1 dash, y2 dash. Okay. So if I'll simply write here 3 by 5, 2 by 5. That means 1 by 5 e power t, adding this. So 1 by 5 e power t. 6 plus 1, that means 7. 5y2, because we can add it, right? Both orders are same. 2 cross 1, 2 cross 1. So we can add 0 plus this. Now this plus this means 7 by 5 e power t. That means y1 dash is this and y2 dash is this. So we have two equations. Y1 dash is 1 by 5 e power t and y2 dash is 5 y2 plus 7 by 5 e power t. Now it's up to you which method you are going to solve these two equations, right? This is non-homogeneous equation if you are going into that like first order differential equation. But I'll suggest you just separate the variable, like dy by 1 by dt, it's this, right? 1 by 5 e power t. So separate the variables. That means dy1 is equals to 1 by 5 et dt, e power t dt. Now integrate it like this. That means y1 is equals to 1 by 5 integration of e power t is e power t plus constant of integration c1. So this is your y1. Now how to solve this? This is in this form: dy2 over dt minus 5y2 7 by 5 e power t. First order non-homogeneous linear differential equation with constant coefficient, right? So it will contain two parts, yc plus yp, right? So for yc means auxiliary equation, m minus 5 is equals to 0, m is equals to 5. That means yc here is c1 e power 5t. Now, because you can use method of undetermined coefficient, right? RHS is e power t and no part of RHS appears in yc. That means let us assume yp is a e power 5t. That means, sorry, a e power t. Because RHS is this. So a e power t. Now substitute here the values yp dash and yp dash only. So yp dash is same, a e power t. So substitute here. That means yp dash a e power t minus 5 a e power t is equals to a e power t minus 5 a e power t. Yeah, it's fine. 7 by 5 e power t. That means a minus 5a, that means minus 4a e power t is equals to 7 by 5 e power t, right? So yeah, that means 4a is equals to this. A is equals to minus 7 by 20. That means yp here is minus 7 by 20 e power t. So combining the solution y2, you will get yc c1 e power 5t minus 7 by 20 e power t. So this is your y2. So once you have y2, y1, then y1, y2. y1 was 1 by 5 e power t plus c1 and this e power 5t minus 7 by 20. 1 by 5 e power t plus c1 and y2 was minus 7 by 20 e power t plus c2, because c2 you can take, and e power 5t. Yeah, because c1 already we have took here, so let us take c2 here. So this is your y1, y2. That means this is your y. If I'll simply take in this form. Now x is equals to py. Py means value of p was the eigenvectors p 1 minus 2 2 1. 1 minus 2 2 1. A value of y 1 by 5 e power t plus c1 minus 7 by 20 e power t plus c2 e power 5t. This is your x. That means x y. If you write in this, so multiply this 1 by 5 e power t plus c1 and 2. That means when we are multiplying by 2, that means 7 by 10 e power t 2 c2 e power 5t. This is your first element of this column matrix. Then minus 2 by 5 e power t minus 2 c1 minus 2 then 1. Okay, minus 7 by 20 e power t plus c2 e power 5t. That means just calculate this and this and e power t this. You will get the value of x as this and y as this. So this was your example related to non-homogeneous system of first order differential equation. Okay, so you can use diagonalization method. It will be a little bit long, but okay, but you should know how to solve this when you will get these two equations where this. Any doubt in this? So I have solved complete question here. Any doubts?
No, ma'am.
Okay, so last topic of not last topic related to matrix method. One topic is left, and this is reduction of nth order differential equation to a linear system of first order differential equation. Means suppose you have nth order differential equation is given, right? And we need to solve this nth order differential equation using matrix method. So first we'll try to convert it into a linear system of first order differential equation like we did in the last question. You will get that type of system and then you can use as usual method like we did in the previous example. So for example, consider this. Now let us write, consider the nth order differential equation. Suppose this is your differential equation. It's n minus 1th derivative. And an minus 1th coefficient related to dy by dt plus any is equals to some function of t, right? So we'll make the following substitution. Now see the substitution carefully, otherwise you will be confused. Substitutions. So what? We'll change the dependent variable y. In many dependent variables x1, x2, xn. So we'll assume, see the substitution carefully. Let x1 is equals to y. x2 is equals to dy by dt. That means simply y dash, right? x3 is equals to second derivative. That means y double dash. That and xn is the n minus 1th derivative. That means yn minus 1, right? Now, see, if I simply take its derivative, both the sides, x1 dash, that means y dash, right? And y dash is equals to x2. Correct? If I take derivative of this, x2 dash, that means y double dash. Here, take derivative of this, and y double dash is equals to x3. So write x3. Take x3 dash, that is equals to y triple dash. Here, and y triple dash will be equal to x4. Similarly, if I take the derivative of, like, before that, it is x minus 1. That will be equal to n minus second derivative of y with respect to t. If I'll take its derivative, that will be equal to xn, right? So xn minus 1th derivative. This is n minus 2th derivative. One more time derivative means n minus 1th derivative. So that will be equal to xn. That means it will be equal to yn minus 1th derivative. That means equals to xn. Right? Simply now you can see that this is nothing but x1 dash is equals to 0 x1 plus x2. You can write this equation as 0 x1, 1 x2, 0 x3, and so on. 0 xn you can say. Right? You got the first order differential equation with many dependent variables. But the thing is, all the coefficient of dependent variable is 0 except x2. Only this equation I am writing in this form. Take x2 dash. From here, only x3 coefficient is 1. All are 0. 0 x1, 0 x2, x3, and so on. Take x3 dash. That means 0 x1, 0 x2, 0 x3, and only the coefficient of x4 is 1. All are 0. That means by making this type of substitution, you will get the first order. See, it was the uncoupled equation that you can solve with any method. Like you can use method of undetermined coefficient, or you can use auxiliary equation method, right? But if the question is first reduce it to the system of equation, then solve it by matrix method, that means you need to make these assumptions. Okay, so let's discuss it with one example, then only it will be clear to you. Okay, so I'll just tell you how to convert it to it into the system of equation, and the solution part that you need to complete. So let's see. Suppose you have this differential equation. Let us say d2y by d t square and y is equals to 0. See, this is very simple equation, or take minus here. That means if you write its auxiliary equation, m square minus 1 is equals to 0, m is equals to plus minus 1, right? That means y is equals to c1 e power t. Now independent variable is t. c2 e power minus t. So this is your answer. But question is, reduce this differential equation into the system of first order linear equations and solve it by matrix method. That means first make a substitution. x1 is equals to, simply write y. x2 is equals to y dash. Because it is second order, so no need up to, only up to x2. If it's 3 order differential equation, assume up to x3. Okay, so x1 is equals to y and x2 is equals to y dash. Now take its derivative. x1 dash is equals to y dash and y dash is equals to x2, right? Now take its derivative. x2 dash is equals to y double derivative, and now y double derivative is, see, from here y double dash is equals to 0, y double derivative is equals to y, right? So y double derivative is equals to y and y is equals to x1. That means everything you need to change into in terms of x1 and x2. So this equation becomes x1 dash 0x1 plus x2. This equation becomes x2 dash x1 plus 0x2, right? Now see, now you can solve easily. This is homogeneous system of first order differential equation. If I simply write x1 dash x2 dash, zero, 1, 1, 0, x1, x2, right? Now you can solve easily. This is your A matrix. Write its eigenvalues. Then eigenvalues, the homogeneous system of equation, you can solve easily. Any doubt in this?
No, ma'am.
Please see it carefully. I will tell you one more example. Now let's see. Suppose you have this differential equation. Randomly I am choosing any. Okay. Now question is, reduce the second order differential equation into the system of first order linear differential equations. Now this is second order because in your syllabus only second order. So substitution, let take x1 is equals to y, x2 is equals to y dash, right? Take its derivative. x1 dash is equals to y dash and y dash is equals to x2, right? Now take its derivative. x2 dash is equals to y double dash, and from here y double dash is equals to 2y minus 3y dash, right? These terms, take these two terms in RHS, okay? Then y value is x1, y dash value is this x2. That means y double derivative is this. So x2 is 2x1 minus x2, right? So this equation becomes x1 dash is equals to 0x1 plus x2, and this equation becomes x2 dash is equals to 2x1 minus x2. That means system become x1 x2 dash 0 1 2 minus 1 x1 x2. Okay, now you can change any equation, but if the question is solved, this means write an auxiliary equation m square plus 3m plus 2, write its roots, then according to the nature of the roots you can write the solution. But if you been asked to solve by matrix method, that means this method. Now it can be non-homogeneous also, right? So in this itself I'll make a change. Let us say,
Ma'am, should it be minus of 3x2? Like y double dash equals to?
where 2y. Yeah, it's minus because minus to 1. So minus
And ma'am, minus 3 also.
3 also. Yeah, okay.
Ma'am, uh,
Yes.
x2 dash you're substituting as minus 2x1 minus 3x2. Instead of that, can we put x3, ma'am? Like x3 is equal to y double dash now, ma'am.
X3.
Yes, ma'am.
No. Then see, if it is second order differential equation, that means you will have two equations only, two dependent variables only. You cannot include x3.
Okay, ma'am.
Okay, it's up to the order of the differential equation. If order of the differential equation is 2, that means you need to include only two dependent variables. That's it.
Okay.
Okay. Now let us change the RHS. Any function of t you want. Suppose e power t only. This is the simplest one. That means same assumption. X1 is y, x2 is y dash. So this. But when you are finding y double derivative, x2 derivative, y double derivative. So y double derivative means minus 2y1, sorry 2y minus 3y dash and plus e power t, right? Plus e power t. Because we are changing the dependent variable, not independent variable. So independent variable will be in terms of t only. That means here you will get e power t, right? That means here the non-homogeneous part is 0, right? And here it is e power t. That means simply write 0 e power t. So this is in the form of x dash is equals to ax plus f form. Then you can use diagonalization method. Y dash is equals to dy plus p inverse f. Okay, so this was the case when you have non-homogeneous part.
I mean, non-homogeneous method can we do without diagonalization? Like for
Without,
homogeneous part without diagonalization, directly we can do now.
we have one method of undetermined coefficient, but it will be longer than this diagonalization process. That's why I haven't told you.
Okay, ma'am. Because for homogeneous you gave one equation, ma'am.
Yeah,
X
homogeneous,
one
that is
x.
easy. But if I'll use method of undetermined coefficient, it will be totally lengthy and you will not be able to understand that method. Even more confused. If you want, I can tell.
Okay. Okay, you
No,
just
if you
explain.
want, then I can tell you that method. But just I don't want to confuse you. That's why I'm not telling that.
Okay, okay, you just leave that. It's enough.
Okay. So next, so we have application part of this, and I think time is over. So in the next class, we'll discuss the application of differential equation for the damped and undamped motion of a spring. Then two models are there only for your syllabus, and one is LRC circuit that we are going to discuss in next class. And your CAT 2 module is up to, sorry, CAT 2 syllabus is up to fourth module. And one more thing, I'll take quiz after CAT 2 exam. Okay, means before final exams I will take quiz. Any doubts?
Ma'am,
Uh,
can you upload the materials?
I will upload, but okay, I will upload.
Ma'am, can you able to upload this handwritten material also, ma'am?
No, I'm not saving it.
Okay, ma'am.
Okay.
Ma'am, yesterday I asked one doubt in Heaviside function, ma'am. That f
Oh,
of t is equal.
your doubt. See, you
Yes, ma'am.
are not simply saying that what I'm trying to say, like second shifting. Let me see that example, then I'll tell you where it was. Okay, Laplace transform and this. Yeah, okay. It was this example. Ft is equals to this one, right? T minus 1, 0,
Ma'am.
when
0.
t lies between 0 to 2.
No, no, 1 to 2, ma'am. 1 to 2.
Okay, 1 to 2. So otherwise, that means, see, I told you to write, means the differential equation was y double dash minus 6y dash plus 5y is equals to ft, right? So using Laplace transform, we need to solve this. So I asked in the class that you find its Laplace transform of this function separately. So first we'll write ft in using Heaviside function, right? So when you have the piecewise continuous function, you can write this using Heaviside function. So u of t minus 1 minus u of t minus 2, and that is will be multiplied by this component t minus 1 plus 0 into u of t minus 2, like that. Means for otherwise, right? So that means t minus 1 u of t minus 1, then t minus 1 u of t minus 2. This is your ft. Now you need to find Laplace transform of ft, right? So take Laplace transform. So Laplace transform of this and Laplace transform of this and this. Now remember the second shifting property.
Yes, ma'am. That f of t minus a u type t minus a is equal to
F of t minus a, u of t minus a is
equal
equals
to
to e power minus as and Laplace
f
transform of ft. See,
ft.
if it is t minus 1, that means it is function t minus a. U t minus a, that means corresponding function is t only. Then only f t minus 1 is t minus 1. When you were writing, I told you that a value is 1 here. If it is t minus a, u t minus a, that means function is t. For this purpose only, I told you that ft is t. I am not telling about this. Already I have written in this form. I have considered this component as t minus 1 only. When I am multiplying this, I took t minus 1. But when I am taking Laplace transform, so you can see the form of t minus a, ut minus a. T minus a, ut minus a. And Laplace transform of ft. It is not showing that, saying that Laplace transform of ft minus a. So we'll simply write a value is 1, so minus s, and Laplace transform of ft, where ft is simply Laplace transform of t. Then only a value is minus 1, right? Now getting this or not?
Yes, ma'am. Got it. Now
Got
I
it?
got it. Yes.
Yeah, that's why I told you, like, I cannot explain on WhatsApp, but I can explain like this.
Yes, ma'am.
Okay,
Now I
then.
understand. Yeah.
Okay. Okay, then I'll take your attendance. mark your attendance. Those who have marked their attendance may leave.
Ma'am,
Yes?
I was present on
You are not audible properly.
Ma'am, I was present on 5th April, ma'am, but you marked as absent.
Your
Hello, ma'am.
yes, you were present on.
17 MIL 0513.
So have you joined on time?
Ma'am, your voice is breaking.
I'm asking, have you joined on time?
Yes, ma'am.
Are you sure?
Yes, ma'am. Sure.
Sarika.
Yes, ma'am.
Okay.
For me also, last class you mark option ma'am.
For lab class.
No ma'am, class. Monday class.
So have you joined on time? I have details.
Yes ma'am, I joined on time. You can check ma'am.
Okay, let me check then. Okay. Yes. I have updated your attendance.